Alright, here is now the next lesson. It's called the method of undetermined coefficients. This is one way of solving non-homogeneous linear differential equation. Now, here is a non-homogeneous linear differential equation, AODN plus A1 dn minus 1 plus and so on, an minus 1d plus any equals f of x, where now our f of x is not equal to 0. Now, the general solution will be the sum of the complementary solution and the particular solution. Now, how do you solve the complementary solution? Okay, the complementary solution will come from the solution of the associated homogeneous linear differential equation. That means to say, okay, if that is homogeneous, f of x is what? F of x is 0. So we know already how to do this in the previous topic. And y sub p is the particular solution, which will depend on the value of this f of x, and which we will determine using this procedure, the method of undetermined coefficients. Now yp, step 1, you form the complementary solution, that is set f of x is 0. So we just solve the equivalent homogeneous linear differential equation. We know how to solve this in the previous topic. And then step 2 is get the particular solution, based on f of x. Now these are the rules, basic rules. If f of x is a e to the gx, then a corresponding particular solution is ae to the gx. If you have small a cosine gx plus small a sine gx, then a corresponding particular solution is a cosine gx plus b sine gx. And if you have a polynomial function a plus bx plus cx squared plus and so on nxn, then a corresponding particular solution is a plus bx plus cx squared plus nxn. Now, next step is you compare yp and yc. Now, if they have similar terms, you will have to multiply yp with either x squared, or until x to the n, until there are no similar terms between yp and yc. And step 4 is you will have to solve for the values of the coefficients. Now you will have to substitute yp into the differential equation and solve for the values of the coefficients by equating coefficients of like powers. And step 5 is get the general solution. The general solution is just the sum of yc and y sub p. Okay, let's have one example. Alright, let's solve this dE. Okay, let's have this as example 1. Let's solve this dE. Y double prime minus 5y prime plus 4y is 3e to the 6x. Okay, step is rewrite the operator form as b squared minus 5d plus 4y 0, and then get the auxiliary equation. You replace d by m. You have m squared minus 5m plus 4 is 0. Okay, find the roots. You can factor this as m minus 4 times m minus 1 is 0. And of course, the roots are 4 and 1. And you can find the complementary solution based on this auxiliary equation, which is what? c1 e to the 4x plus c2 e to the x. Now, next step is we will have to analyze, this one, the right side. The right side is 3 to the 6x, and see in the table where does 3 to the cx lies. This is here, ae to the gx. So a corresponding particular solution is of the form a to the gx. That's why you have what? A particular solution is Okay, AE to the 6x. Now the next step is you have to compare. Is there is there any similarity between YP and YC? This is C1 e to the 4x and C2 e to the x. This is A to the 6x, so nothing similar, so you can proceed. Now the next step is this must satisfy this differential equation. You notice that I put P here because we're going to find the value of P based on this equation here. So you put yp double prime minus what? Minus 5yp prime plus 4yp equals 3 e to the 6x. And okay, you need to find yp prime and yp double prime. So here yp is a e to the 6x. The next derivative is 6a e to the 6x, and the next derivative is 36a e to the 6x. And the next step is you will have to plug. Okay, you will have to plug these values there, okay, there and there, to find the value of what? To find the value of a. So this was plugged. Okay, notice that this was plugged. Yp is plugged there. That is 4 times a e to the 6x. That is 5p prime. That is negative 5 times 6a e to the 6x. And this one is yp double prime is 36a e to the 6x is 3 to the 6x. This can be combined. This is 36 minus 30 plus 4. That gives you what? That gives you, okay, that gives you 10. A e to the 6x is 3 to the 6x. And of course, you have 10a is 3. Okay, equating same variables here, and then you can solve for a. Your a is 3 over 10. Now remember that your y is the sum of yc and yp. And here we have our y sub c is c1 e to the 4x plus c2 e to the x, and we have our yp as what? Our yp as, we know this already, this is what? This is, okay, this a is what? This a is already 3 over 10. So therefore, we just substitute. Okay, this comes from, this is y sub c, and this is y sub p, which is this one. So we now have the general solution. Y equals, okay, here, y equals c1 e to the 4x plus c2 e to the x plus 3 over 10 e to the 6x. Alright, let's have another example. Okay, let's call the example 2. Okay, let's have this, okay, y double prime plus 4y equals 3 sine 3x. Okay, the next step, of course, is rewrite this into, okay, into an operator form. This is d squared plus 4y. Okay, actually this is should be equal to 3 sine 3x. 3 sine 3x. Okay, then get the auxiliary equation of the equivalent homogeneous equation. So that gives you what? M squared plus 4 is 0. Of course, the roots are, these are 2i, and you solve for m squared plus 4 here. The roots are 2i and negative 2i. Remember, this is the same as m equals square root of negative 4 plus and minus, and therefore this is plus minus 2i. Okay, so okay, the solution of the auxiliary equation becomes y sub c, or complementary solution, is c1 cosine 2x plus c2 sine 2x based on these roots of 2i and negative 2i. Then to get y sub p, we will analyze this one, 3, okay, we'll analyze this right side, which is 3 sine 3x. Now where is it here? So here it is located here. Okay, so our general solution is this one, of the form a cosine qx plus b sine, or rather gx plus b sine gx. Therefore our y sub p is equal to a cosine 3x plus b sine 3x. Now compare y sub c and y sub p now. Are they the same? No, they are not. So cosine 2x and sine 2x, okay, is different from cosine 3x and sine 3x. So we will now proceed with the next step. Okay, your particular solution must satisfy this differential equation here. Okay, we will just put p here. Y sub p double prime plus 4y sub p is 3 sine 3x, so that we can determine the value of a and b. Okay, so we need yp prime, and yp double prime. Our yp is a cosine 3x plus b sine 3x. The first derivative is, of course, negative 3a sine 3x plus 3b cosine 3x. The next derivative is negative 9a cosine 3x minus 9b sine 3x. Now notice that you will have to what? Plug it. Okay, you will have to plug yp double prime there, and you will have to plug yp there. So the resulting equation will give you what? Will give you, okay, this is yp double prime, it's here, negative 9a cosine 3x minus 9b sine 3x, plus of course this is what? This is for yp is a cosine 3x plus b sine 3x is 3 sine 3x. And then simplify, this is negative 9 plus 4, that's negative 5a. This is negative 9 plus 4b, this is also negative 5b sine 3x is 3 sine 3x. Now you have to create coefficients of like variables. So observe that what? That this, your negative 5a there has no cosine 3x there, no? And your negative 5b there is the same as 3. So your next equation is negative 5a is 0 and negative 5b is 3. Okay, therefore your a is 0 and b is negative 3 over 5. Therefore you know already y sub p. Remember, this is our y sub p. Okay, this is our y sub p there. Okay, where our what? Our a is already what? 0, and our b is what? Our b is negative 3 over 5. Okay, therefore we have our y sub p is what? Our y sub p is negative 3 over 5 sine 3x, and the general solution is the sum of the complementary and particular solution. Okay, here is our what? Here is our y sub c, and already we know already y sub p. Our y sub p is this one. So add the complementary and particular solution. We have the general solution, c1 cosine 2x plus c2 sine 2x minus 3 over 5 sine 3x. Okay, let's have another example. Okay, let's do this one. Y double prime minus 5y prime minus 24y is x cubed. Okay, write that in operator form. That's d squared minus 5d minus 24y is x cubed. Then get the roots of the characteristic or auxiliary equation. That is m squared minus 5m minus 24 is 0. Okay, that's the same as, you can factor this. This is the same as m, and then minus m minus 8, and then m plus 3 is equal to 0. So this is negative 8 and this is 3, that's correct, 3m. So the roots are therefore what? 8 and negative 3. And okay, the solution of the equivalent homogeneous equation, or the roots of the auxiliary, or the characteristic equation, is what? Z1 e to the 8x plus C2 e to the negative 3x, based on the roots of the auxiliary equation 8 and negative 3. Then, and then we will now analyze this one. Okay, the right side is x cubed. Okay, where does it fall? It falls in this case, there, in this case. So, okay, this is x cubed, so our general solution is a plus bx plus cx squared plus nxn. So that's our what? This is our what? Our particular solution. Now you will have to compare y sub p with your y sub c. Now obviously they are different, so our y sub p will stand as only this one. A plus bx plus cx squared plus dx cubed. Remember, you have to find the values of a, b, c, and d by what? By solving, okay, by plugging this in this equation. Look, this should be yp double prime here minus yp prime minus 24yp equals x cubed. Now we have to find those yp, yp prime, and yp double prime. Our yp is of course a plus bx plus cx squared plus dx cubed. Our yp prime is b plus 2cx, derivative of that, plus 3dx squared. And our yp double prime is just 2c plus 6dx. Okay, now remember that you will have to plug. Okay, you will have to plug all these values here. Y sub b will be plugged there, yp prime will be plugged there, and yp double prime will be plugged there to find the values of a, b, and c. And then the result, look at the result, is what? Okay, this is 2c plus 6dx. This is our yp double prime. This is our yp prime, which is this one, b plus 2cx plus 3dx squared. And this is our what? Yp. This is our yp double prime. This is our yp prime, and this is our yp. So you will have to get the values of a, b, c, and d. Now you will have to combine. Okay, you will have to combine them. Okay, you will have to combine them. Okay, let's just remove this. Okay, you will have to combine all what? All coefficients of the same power. So all the constants is here. Where are the constants? You have 2c, 5b, and 24a here. Therefore, you have 2c minus 5b minus 24a there. And then you have to have that x. What are those x coefficients for 6d? It's there. And then here minus 5 times 2 is just minus 10c. And then here minus 24 times b is this one, minus 24b. So these are all coefficients of x. The coefficients of x squared, you have only 2. This is negative 5 plus 3d times 3d is negative 15d. And you have negative 24 times c is negative 24c, then x squared. And then you have only one x cubed, that is negative 24 times d. It's negative 24 dx cubed is x cubed. Now we can now equate coefficients of like powers there. This means that for x cubed, okay, here, negative 24d is the coefficient of x cubed there. Therefore, you know already what? You know already d. Okay, your d is what? Negative 1 over 24. Now, using this x squared, now this one, negative 15d, look at that. So there is no coefficient for, right, there is no x squared in the right side for x squared. So you have negative 15d minus 24c is 0. What you do is plug the value of d there. okay, and solve for c. So actually you have to plug that negative 15 times negative 1 over 24 minus 24c 0, and therefore you get this value of c there, which is 5 over 192. Remember, you know already the values of c and d. The next is for this coefficient of x d. There is no x term in the right side also, so therefore we have 6d minus 10c minus 24b is 0. Now you know that you know already what? You know already the value of d, so you know already the value of d, you know already the value of c, so it's possible for you to get the value of b here. So your b is actually equal to what? 6d minus 10c over negative 24. So substituting these values there for c and d, you get this value of b. Right? Same concept is this for a constant here. For a constant, there is no constant. This is 2c minus 5b minus 24a is 0. Okay, remember, okay, you know already the value of c and b. Your a here will just be equal to 2c plus what? 5, rather, negative 2c. I'm sorry. Uh, that's okay. That is, by the way, your a is, alright, how do you get a? Your a will be just 2c minus 5b divided by 24. Okay, you know already the value of c there, you know already the value of c, and you know already the value of what? The value of b. So substitute that, and then you get this value of a. So once you get the values of a, b, you know, we're not complete. We know already the values of a, b, c, and d. So plug it here again. Remember, you know the value of a, b, c, and d. You get the particular solution. Your particular solution is what? 360. Yp is 365 over 55296 minus 49 over 2304x plus 5 over 192x squared minus 1 over 24x cubed. And therefore, your y is just the same as y sub c plus y sub b. And your y sub c is here, there, and then your y sub b is there. Just combine. You have the general solution. Y equals c1 e to the 8x plus c2 e to the negative 3x plus 365 over 55296 minus 49 over 2304x plus 5 over 192x squared minus 1 over 24x cubed. Okay, let's have the fifth example. I think this is the fourth one. Fourth example. Okay, solve y double prime minus y is 3 to the x. Now rewrite this in operator form, that is what? That is d squared minus 1y is 3 to the x, and find the equivalent solution of the homogeneous equation. Okay, m squared minus 1 is 0, replace d by m, then solve for m. The roots are of course 1 and negative 1. Okay, then your complementary or auxiliary equation is c1 e to the x plus c2 e to the negative x based on the roots 1 and negative 1 of the auxiliary equation. Now analyze now this 3 e to the x. Okay, analyze now this 3 e to the x, this one. Alright, now our yp will be, based on our table, should be a e to the x, and then compare the two. Okay, you notice that a e to the x
is the same as c1 if dx. Okay, if you combine them they will be the same. So the cure here is to multiply. Okay, the cure here is to multiply, okay, yp by x. So the revised yp will be what? Will be ax e to the x. And compare it again here. Is there anything saying there's none already? So yp now will be ax e to the x, and we will have to determine a. Okay, from the equation this should satisfy yp double prime from here minus yp equals 3 to the x. Okay, and then we have to solve for a. We need to find yp and yp double prime. Now this is yp ax to the x, yp prime. Okay, notice your yp prime. Okay, your yp prime is the same as what? Okay, a. Now this is a derivative of a product x e to the x plus another one e to the x. Okay, so that is here, and then your yp double prime. Okay, this will be repeated again. So a times x e to the x plus e to the x plus what? Plus a e to the x. That's why this combines, and you have what? And you have I'm sorry, this combines, I mean this one combines, um, this one combines. Okay, and then you have what? And then you have 2a e to the x there, and then ax e to the x. So alright, substitute it in what? This should be plugged here. So your yp double prime will be plugged there, and your yp will be plugged there. So you get what? Oh, you get ax e to the x plus 2a e to the x, and then minus ax e to the x. Observe that this ax e to the x will cancel out there. So this will cancel out, and this will cancel out. So what remains is only what? 2a e to the x. And therefore if you combine, and therefore your 2a is 3. Okay, your a is 3 half, and substituting it again here in this equation, yp, we know already the value of a. Then yp is 3 halves x is the x. And remember that, okay, your solution is the sum of the complementary and particular solution. Okay, this is our complementary solution, this one. So you'll have to plug it there. Okay, c1 e to the x plus c2 e to the minus x plus 3 half x e to the x. Okay, let's have now the sixth example. Okay, let's solve y double prime plus y prime minus 2y is 2x minus 40 cosine 2x. Now here we have two different yp's here. Okay, we will use now superposition. The first step, of course, is to set this up in terms of its operator form. D squared plus d minus 2y is 2x minus 40 cosine 2x. Then find the solution of this equivalent homogeneous equation. Okay, how do you factor this? Okay, this is m. Alright, this is m minus okay, m plus 1, rather m minus 1 times m plus 2 equals 0. So the roots are what? The roots are 1 and negative 2. And then y sub c now, based on this 1 and negative 2, has a solution of, or complementary solution is c1 e to the x plus c2 e to the negative x. Now let's have yp1. We're going to analyze first 2x here, okay, and then later on this negative 40 cosine 2x. So based on this 2x, our 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 particular solution is a plus bx. Now compare it to that y sub c. Alright, there is nothing different there, therefore we will accept this a plus bx. Okay, so we will have to determine a and b, okay, based on, because this should satisfy, okay, this is the original equation, this should satisfy yp1 double prime plus yp1 prime minus 2py yp1 equals to x. Okay, so we need to get that yp1, yp1 prime, and yp1 double prime. This is your yp1, a plus bx. Your yp1, that's the derivative of a plus bx, is b, and the second derivative is 0. The next step is, of course, you will have to plug it there. Yp1 double prime will be plugged there, yp1 prime will be plugged there, and yp1 will be, okay, and yp1, sorry, this is and then your yp1, okay, your yp1 will be plugged there, and your equation now becomes what? uh, 0, okay, plus what? Plus b, okay, minus 2, this is your yp double prime, plus b minus 2, okay, times yp1 is a plus bx equals to x. And then, okay, simplify this. This is the same as what? B minus 2a plus minus 2bx is 0. Now observe that your b minus 2a here, your b minus 2a there will just be the same as 0. And your negative 2b equating coefficients of like powers will be the same as 2. Okay, therefore from here b is negative 1, here b is negative 1, and plugging it there, b is negative 1, then your a is what? Your a is negative 1. And your yp now, substitute there, is negative 1 minus x. So we need we go to yp1. Now your yp2 now will be based on this one, negative 40 cosine 2x. Okay, now your trial yp2 is c cosine 2x plus d sine 2x. Now compare it with the original equation here. Okay, are there similarities? There's none, so we will accept that this is yp2 is c cosine 2x plus d sine 2x. Okay, and we will have to determine c and d based on that yp2 should satisfy this differential equation here, with the right side is negative 40 cosine 2x. So we need yp, okay, we need these values yp2, yp2 prime, and yp2 double prime. Your yp2 is c cosine 2x plus d sine 2x. Get the next derivative, that is negative 2c sine 2x plus 2d cosine 2x. Okay, second derivative is what? Negative 4c cosine 2x minus 4d sine 2x. And then remember, you will be plugging it. Okay, this will be plugged here, this will be plugged there, and this will be plugged there. So plugging, okay, you will have, okay, you will have this what? Okay, you will have this setup. Now, okay, yp2 here is negative 4c, this one, negative 4c cosine 2x minus 4d sine 2x. your yp2 is here. Yp2 prime is negative 2c sine 2x plus 2d cosine 2x, and then minus 2, your yp is just what? C cosine 2x plus d sine 2x, that is equal to negative 40 cosine 2x. And then combine, okay, combine all what? Just combining, okay, all the cosine 2x. So all the cosine 2x, this one is negative 4c, and this is negative 2c, that is negative 6c, and then another cosine 2x is this one, 2d cosine 2x, this is plus 2d here. And then combining all the sine 2x, okay, this is the sine 2x, or sine 2x is this one, negative 4d. Okay, let's begin with the c, negative 2c first, it's negative 2c. Okay, this is the only sine 2x, and then for the d, you have negative 4d, and then here negative 2 times d is negative 2d, negative 4d minus 2d is negative 6d, sine 2x is negative 40 cosine 2x. And therefore, for cosine 2x, you have negative 6c plus 2d is negative 4d, and then for sine 2x, it is negative 2c minus 6d, 0. You will have to, okay, you will have to solve this simultaneously. Okay, let's try it manually. Let's multiply, okay, let's multiply this by okay, let's multiply this by okay, let's multiply this by c, by this equation. Okay, here let's multiply that by, okay, let's see how can we multiply that. Let's multiply this by negative 3. So if you add that, you will have what? This will be eliminated, there will be eliminated, this will be what? This will be 2d plus 18, that is 20d, is equal to negative 40. Therefore, d is negative 2. Now, if d is negative 2, then we can just use 2c is negative 6 times negative 2. Therefore, rc is what? rc is 6. So these are our values. C is 6 and D is negative 2. Then your YP2. Alright, if you use this now, equation C and D, your YP2 is 6 cosine 2x minus 2 sine 2x. And then you know already that YP, just add the original. This is YP1 and YP2. So your YP will be YP1 plus YP2, and this one, YP is negative 1 half minus x plus c cosine 2x minus 2 sine 2x. And of course, your y will be the sum of the complementary solution and the particular solution. This is our complementary solution. This is our particular solution. Then add them. Then you have the general solution. Okay, c1 e to the x plus c2 e to the negative 2x minus 1 half minus x plus 6 cosine 2x minus 2 sine 2x. Okay, let's have this seventh example. We have d squared plus 1y is cosine x. Alright. Now, the equivalent auxiliary equation is the solution of the equivalent homogeneous equation. This is m squared plus 1 is 0. Okay. The roots are m plus minus I, and therefore your y sub c is c1 cosine x plus c2 sine x.
Now your y sub p is of course based on this cosine x there. Your y sub p is okay a cosine x plus b sine x. But if you compare these two, okay, they are the same. Okay, so what you do is you have to revise y sub b. Okay, y sub b can be found by multiplying this by x. And then so your y sub p is ax cosine x plus bx sine x. And compare. Okay, compare. Okay, is this similar to this? No longer similar. So we will consider this as already y sub b. Now remember that this is the same as what? This is the same as y uh, double prime plus y is equal to cosine x. And this should satisfy also yp. So put yp there. So we can determine now the value of a. So from this equation. Okay, so we need yp prime and yp double prime. What is your yp prime? Your yp prime is a times the derivative of a product here. This is x times negative sine x plus cosine x times the derivative of x is 1 plus b times x times the derivative of sine x is cosine x plus sine x times the derivative of x is 1. Okay, simplifying, we have yp prime is a times negative x sine x plus cosine x plus b times x cosine x plus sine x. Then you need to get yp double prime. This is again a product. This is negative x, okay, times the derivative of sine x is cosine x, and then plus sine x times the derivative of negative x is negative 1, so you have negative sine x. The derivative of cosine x is negative sine x. Here plus b times x times the derivative of cosine x is negative sine x plus cosine x times the derivative of x is 1 plus the derivative of sine x is cosine x. And simplifying, we have yp double prime is a times negative x cosine x minus 2 sine x plus b times negative x sine x plus 2 cosine x. Now it should satisfy this equation yp double prime plus yp is cosine x for us to determine a and b. Okay, our yp double prime should be plugged here and your yp should be plugged there. Okay, so we have this equation. So this is already what? This is yp double prime, that is a times negative x cosine x minus 2 sine x plus b times negative x sine x here plus 2 cosine x plus your yp. This is your yp there, that is ax cosine x plus bx sine x equals cosine x. Now observe that some things will cancel out here. You have this negative 8x cosine x cancels with that, and you have bx sine x cancels with this. So all you just have is cosine 2x, and then you have cosine 2x, you have 2b here. Cosine 2x, alright, cosine x you have 2b, and then sine x there you have negative 2a equals cosine x. And therefore your 2b, what's the coefficient of cosine x? There is 1. 2b is 1 and negative 2a is 0. Therefore b is 1/2 and a is 0. Then we will have to use our yp. This is our yp again. This is yp. We can substitute the values of a and b there. So your y sub p is, okay, since your a is what? 0, so you just have b is 1/2 x sine x. And remember, your y is the sum of y sub c and y sub p. And we have this y sub c as c1 cosine x plus c2 sine x and yp is 1 half x sine x, and therefore your y is c1 cosine x plus c2 sine x plus 1 half x sine x. Okay, that's the solution. Okay, let's have the eighth example. This is the eighth example. Now let's have d squared plus dy is x squared. Okay. Okay, the step is to find the auxiliary equation. Let's just have m squared plus m is 0. You can factor that as m times m plus 1 is 0. Well, obviously the roots are 0 and negative 1. And your solution is y equals c1 plus c2 e to the negative x. Okay, notice that uh, that's the same as y equals c1 e to the 0x plus c2 e to the negative x. That's why it's just c1. Next is your yp based on this. Look at this x squared. Your yp based on this, okay, should start with a plus bx plus cx squared. Now you will have to compare. Okay, you will have to compare these two. Is there something the same? You notice that C1 and A are the same. So there should be no similar terms here. So to cure that, you will have to multiply this by x and try to compare. The revised yp is already what? Is already ax plus bx squared plus cx cubed. Now compare. Is yp similar to y? Okay, by the way, this uh, this solution is actually complementary solution. We call that y sub c. Okay, so there is no similar terms already. Now remember now that based on this what? Based on this differential equation here, okay, yp should satisfy the differential equation. Put yp double prime plus yp prime is x squared. And you need yp prime and yp double prime. Okay, now what is your yp prime? Get the first derivative of this. This is a plus 2bx plus 3cx squared. And the second derivative is 2b plus 6cx. Okay, notice that you will have to plug, this equation there and plug this equation there in order for you to get the values of a and b. So plugging, okay, notice that you have already what? 2b plus 6cx plus a plus 2bx plus 3cx squared equals x squared. You will have to equate coefficients of like powers. Okay, arrange the constants, that is a and 2b is there. Arrange the x, this is 6c and 2b, this is 6c and 2b there, and arrange the 3cx squared, this is 3cx squared is x squared. Now, equate coefficients of like powers. Obviously, a plus 2b is 0, 2b plus 6c is also 0, there is no x there, and 3c is 1 because of that x squared there. Okay, look at this. Okay, let's just erase this. Now, to get the value of z, look at this. You get c is already 1/3 here. And then b can be computed from this equation. B is negative 3c. That is negative 6 divided by 2. And substitute negative 1/3 there. So this is negative 3 times what? Negative 3 times 1/3. This is negative 1. You know already negative 1. From here, a plus 2b is 0. Therefore, a is negative 2b. And you know that what? And you know that b is already what? B is already what? Negative 1. Therefore, a is 2. So A is 2, B is -1, and C is 1/3. So we will use this equation, this one. This is our particular solution, and therefore our particular solution here is what? Is ax plus bx squared plus cx cubed, plugging the values of what? A, B, and C, you get what? Yp is 2x minus x squared plus 1/3 x cubed. And then of course your y is the same as y sub c and y sub p. Here is your y sub c, that is c1 plus c2 e to the negative x, and your yp is 2x minus x squared plus 1/3 x cubed. Then this is your general solution. Y equals c1 plus c2 e to the negative x plus 2x minus x squared plus 1/3 x cubed. Now let us verify this one, this term here. Now remember our yp is what? Is 2x minus x squared plus 1/3 x cubed. Now what is our yp prime? That is 2 minus 2x plus just x squared. And what is your yp double prime? That is what? -2 plus 2x. Notice that if you add yp prime and yp double prime, these two, -2 and -2 cancelled out, -2x and 2x cancelled out, and the remaining is x squared. So this just verifies this what? This x squared there. Okay, so that will serve as a check in order for you to determine if your yp is right or wrong.